Okay, so today's video is about potential and kinetic energy. But before we talk about those, let's talk about what energy is in general. Energy is the ability to do work. And work is moving things, heating things up, speeding things up, any kind of motion or action. Okay? So energy is the ability to do that. We use energy during every minute of every day. There's energy all around us. We use it, things we use it, other people use it, it's everywhere. Something important to know about energy. Energy is not made of matter. You can't hold it, you can't touch it, it's not stuff, all right? But it does affect matter. So it is not made of matter, but it affects matter. It's an important difference. So make sure you understand the difference between those two. The first type of energy we'll talk about is potential energy. Potential energy is energy that is stored. The object is at rest. So when you have potential energy, you're not moving, you're not doing anything, you're sitting there. And it has the potential to do something, but it's not doing it yet. There are two things to keep in mind when we're talking about potential energy. More mass equals more potential energy. So two things have different masses. Whatever is bigger has more energy. So here we have two objects. They're both 1 meter in the air. And one is 2 kilograms, has a mass of 2 kilograms, and one has a mass of 10 kilograms. So which one will have more potential energy? 2 kilograms or 10 kilograms? 10 kilograms, right. So the bigger object has more potential energy. That's our winner. Also, more height equals more potential energy. So if you have two objects that are the same size, but they're different heights, then whichever one is higher up has more potential energy. So here we have two objects. They both have a mass of 2 kilograms. One is only 1 meter in the air, while another one is 5 meters up off the ground. So which one of these two would have more potential energy? Right, the one that's 5 meters off the ground. So since both of these are the same size, whichever one is higher has the most energy. So this one is higher, so it wins. Okay. So the other type of energy we're going to talk about today is kinetic energy. And kinetic energy is the energy of motion. So in this case, the object is moving. If you have more mass, then you have more kinetic energy. So just like with potential, whichever object is bigger has more kinetic energy. Whatever one is bigger has more kinetic energy. So here we have two objects. They're traveling at the same speed, the 10 kilometers per hour. One is 2 kilograms and one is 10 kilograms. So which of these two would have more kinetic energy? Right, this bottom one. So again, same speed, but different masses. So whichever one is bigger, more mass equals more KE. This one has more kinetic energy. And you may see me abbreviate PE for potential energy and KE for kinetic energy, and that's just to shorten, demand of writing. Also, more mass and also more speed equals more kinetic energy. So if you have two objects of the same size, but they're traveling at different speeds, whichever one is faster has more kinetic energy. So here we have an object that is 2 kilograms, and it's moving at 5 kilometers per hour. And over here, we have an object that is also 2 kilograms, but it's moving at 10 kilometers per hour. So which of these two objects would have more kinetic energy? Right, it's this one over here. Since this one is traveling at 10 kilometers per hour, it's faster than this one, so it has more kinetic energy. Okay, so real quick, we're going to discuss a law of conservation of energy. We will also touch on this in a future video, but I wanted to introduce it at least a little bit. So, something to keep in mind with energy is that it is not created or destroyed. It doesn't come out of nowhere, and it doesn't disappear. Whatever energy we have gets transferred from one type of energy to another, or from one object to another. But energy does not, you don't make energy, and you also don't get rid of energy. You just change what it looks like. So the amount of energy at the beginning equals the amount of energy at the end. It just might look different. Just a side note, energy is measured in joules, which is a capital J. So just like meters has an M, or kilograms has a kg, this is the unit for energy, and you put a capital J. So make sure you always put that, because you have to have the unit in order to have full correct answer. So I'm going to do an example, so maybe this makes a little bit more sense. So say we start with 100 joules of potential energy. It's how much potential energy an object has stored in it. Once it starts moving, it has 95 joules of kinetic energy. It also has 5 joules of heat, which is another type of energy. So if you look here, the 95 plus the 5 equals the 100. So there's 100 on this side that we started with, and there's 100 on this side that we ended with. It just looks different. So here it was all potential energy, and here it's kinetic and heat. But the numbers, 100 on this side, 100 on this side, are the same. Okay, so we're going to do one more example. So say I start with 20 joules of potential energy. So whatever object I have, it's sitting still, it's not moving, it has potential energy in the amount of 20 joules. And again, this is just the unit that we measure energy in. If, once it starts moving, it has 14 joules of kinetic energy, then how much heat, how many joules of heat must it have? So remember, if we have 20 on this side, we must also have 20 on this side. But we only have 14 so far. So what number should go in here? We add 14 to make this side 20. So this side needs to equal 20 joules as well. So what number should go here? Okay, it's going to be 6. Needs 6 joules of heat. So here 14 plus 6 is 20, which matches the 20 that we started with. So whatever number you start with, you must end with. It's just going to look different. Okay? And again, we'll do more with that in a future video. And then lastly, we're going to talk about how potential and kinetic energy change from one form to another. So please keep in mind, energy gradually changes from potential energy to kinetic energy and back. It gradually changes from one to the other. When an object starts moving, it doesn't automatically have 100% kinetic energy. It has a little bit of kinetic energy, and then it builds and builds and builds until it stops again. So we're going to pretend that this is a roller coaster at Six Flags, and we're going to look at each point on the roller coaster to decide what the potential and kinetic energy look like. Okay? So here we have potential. It's going to be red because it's stopped. Okay? Stored or stopped energy. And we're going to do green for kinetic energy because it's going. So stopped and going. So at the beginning here, it's just, the car is just sitting there on the track. Okay? It's not moving yet. So if it's not moving, it's going to have 100% potential energy and 0% kinetic because it's not moving at all. Okay? Hopefully this one makes a lot of sense. So when we're halfway up the first hill, we are moving now. Okay? So we're halfway up. So we have 50% potential and 50% kinetic. Okay? We're still adding up to 100%. But we're halfway up, and we've changed half of that potential energy into kinetic. Okay? Then up here, at the very top of the hill, we're paused again. When you get up to the very top of the hill, you notice there's like a pause before you go back down. So here, we are 100%, excuse me, take that back. We're stopped for a moment. So you're 100% kinetic again, and 100% potential and 0% kinetic. So then as we come back down, we're changing that potential energy back into kinetic energy. So now we're about halfway down, so 50% potential 50% kinetic. Okay? Here, we're all the way down the bottom of this hill. And so when you reach the bottom, you're at your maximum kinetic energy, when you've reached the bottom of like a big hill. So here, we have 0% potential and 100% kinetic. Everything was up here has now completely turned into kinetic. Here we're up a smaller hill, but again, we're about halfway up this hill, so we're about 50% potential and 50% kinetic. Here, it's going to be just like the top of this hill, it's just smaller. So we have 100% potential energy and 0% kinetic. And then here, once we finish, the train has come to a complete stop. We're getting off the ride, and we also have 100% potential and 0% kinetic. So as you can see, as you go through the roller coaster, it switches. It goes up and down and up and down. And you start with potential, you gain speed, you're moving up, potential again, you go down, and it changes from one form to another. So my question here is, say we have point A and point B. Point A is here, and point B is here. Of these 2 points, they're both 100% potential energy, but of these 2 points, which one would have more total potential energy? A or B? Which one's going to have more potential energy? Remember, we learned that more mass and more height equals more potential energy. So it's an A or B. Let's give it A. Since A is so much higher than B, A has the most potential energy of this entire picture. Okay, so the most amount of potential energy is here at the highest point of the ride. So at what point are we going to have the most kinetic energy? That's another good question. Remember, more mass or more speed equals more kinetic energy. So say we have spots, we'll do spot C here and spot D here. So C or D. Which of these spots is going to have the most kinetic energy? The energy of motion. C or D? It's going to be D. Because the train, the roller coaster car at this point, has had this entire hill to pick up speed. So at this point right here on this roller coaster is the fastest that train is moving. So you have to think about it like this. The highest point on your picture is where it has the most potential energy. Then, usually, whatever spot is after that, like the lowest point after the potential energy spot, is going to be your highest kinetic energy. It's not necessarily the spot that's immediately after the spot with potential energy. Like this one's right after it, but it still has this much room to go to pick up speed. So this spot has the most kinetic energy, and this spot has the most potential energy. And again, we will go over this some more.